All right, good day. Hope that you're doing well. So in this video, we're gonna be continuing with your Euclidean questions, right, from your 2022 paper. And to be specific, we have done the grade 11 part, which has the first part of your Euclidean that is examined. Now, the second part of your Euclidean that is examined it relates to grade 12, right? So basically triangles, proportionality, as well as similarity theorems, right? But now, to get into this, before I go about answering these kind of questions, first, what I like to do is that I like to separate my triangles whereby I have a line parallel to one side of a triangle, right? So I try to draw them separately. Now, if you look into this triangle, I'm going to highlight the first one, triangle A, G, C, right? So I'm first going to highlight, I'm going to try and draw it on the side alone. So this is A, G, and C. And here, GC is going to be parallel to ED in this triangle here. All right. And I'm going to draw the other triangle, which is still the same triangle, but then I'm just going to separate them, right? So it's still the same triangle, but now here, I'm going to draw this one. So this is still A, G, and this is C. Now in this triangle, it's parallel to this line, which is D, F. So this is the first step before I can go about answering any questions, right? And after the second step, it would be to write down my given, right? Whatever that I'm given. Now, in accordance to this information here, I'm being told that AG is equals to GB, right? So the line from A to G is equals to GB. So these two lines, AG, are equal, right? Now, AG is equals to, so these are equal. Now here they're telling us that ED, right, is parallel to GC, all right, so already I've made note of that, as well as DF is parallel to AB. All right, now done with that. So now here, first question, we need to prove that CF over FG, right? Now, okay, let me name this triangle here. This line here, it's ED. All right, so now I need to prove that CF over FG. Now let me look at which triangle can I make use of that ratio, CF over FG. So I can use this other triangle here. If I take C, F divided by my FG, right? So here, I'm going to use the very same triangle, right? So CF over FG, I need to prove that this is equals to GE over EA, right? So this is the same as your GE over EA. Now, this is on the other triangle, GE over EA, right? Now, can you see that both these triangles, they have a common side, which is this side from A to D to C, right? So here, first I could say, right, my CF over my FG, this is the same as CD, right, which is that over my DA. And my reason, I have a line parallel to one side of a triangle, right? And that line is DF, it's parallel to AG, all right? Now, also, I could do the same for the other triangle, right? I could say that, all right, my CD in the other triangle, of which I'm going to write in purple, right? So in the other triangle that I've drawn here, my CD divided by DA. Now, this is equals to GE divided by EA. And why is that? I have a line parallel to one side of a triangle, right? And as I've said, this is common, right? This line right over here, you CD over AD, right? And because this is common, you can now conclude that, so this would be your final answer. So you can now say, therefore, remember what we're trying to prove, it's CF over FG is equals to GE over EA. Therefore, CF over FG, it is the same as GE over EA, right? Now, moving on to the next question. Now, they're telling us that if CF over FG is 2:1. Now they've given us the ratio between the two. So let me try and indicate that on my sketches. So CF over FG. So where's my CF? So CF, this is 2:1. So let me put the R. So CF over FG It's 2:1, meaning that same applies to this other side. It's going to be 2r, going to be 1r, and basically all these lines in your triangle, right? So let me try and erase here. So this is going to be 1r. Now, we need to determine the ratio of GE is to GA, right? So we need to try and determine the ratio of GE, which is in this triangle, it is to GA, right? So the ratio from G is to GA, the ratio from G to E is 2R, and the ratio from G to A is going to be 2R plus 1R, which is going to make 3R. So as a result, the ratio between these two is going to be 2:3. And this would be your answer, right? So now let us see what the next question is requiring from us. Determine the numerical value of DF is to AB, right? So let me try and see where is my line DF as well as AB. First, let me try and erase all of this so that this could be clear. So to answer this question, I'm going to try to use what I've calculated before, right? Remember before, I found the ratio of GE is to GA as 2:3. Now, here, I need to determine the ratio of DF is to AB. Now, can I find DF? All right. Now, how can I go about finding DF? So the first step would be to find DF. Now, as you could see, this is my line AB, right? Now, I feel like it would be easier to find DF, like making use of so let me see here. Okay, I can make use of similarity theorem. Why is that? If you know these two triangles, right, they are equiangular. Basically, they have the same angle. This angle A here is equal, this is the same triangle. It's equal to this angle A. This angle G here is equal to this angle G. This angle C here is equal to this angle C. So basically, this is the same triangle, meaning that I can use the similarity theorem with regards to triangles, right? So now I will just write that for the purpose of understanding. I can just write triangle AGC. It's similar, it's the same triangle AGC, right? If you want to, you can write this, but then if you don't, you can just leave it, right? I'm just going to write it for the purpose of understanding. Reason it's angle, angle, angle. As I've said, this is the same triangle. Now, it simply means that I can choose any two ratios in these two triangles and I can equate them to one another, right? So here, I could remember I'm looking for my D. So here, remember I said the first step it's looking for your DF. So I'm looking for my DF. So I'm going to say DF on this blue triangle, right? DF over, do I have my line from A to G? So here I have my A to G, which is 3R, right? So over AG, it equals to, now on the other triangle, which is in purple, right? So which sides can I choose? I can choose AE over AG, right? So I can just write AE over AG, right? And why is that? Because of the similarity, right? These two triangles are similar to one another, right? So similarity theorem. So now, as a result, right, I'm trying to determine my DF over my AG, which is 3R, and this is equals to my AE, right, which is 1, divided by my AG, which is 3R. Now, remember I'm looking for DF, so I'm going to multiply both sides by 3R to get rid of this 3R. So these two are going to cancel out. Let me just draw a line here, multiply this side by 3R also. Now, as a result, my DF, it will be equals to 1R. So I found my DF to be equals to 1R, right? So now, how would I find my AB, right? So to find my AB, can you see that AB, so this triangle ABC, right? Because I don't have a line parallel to one side of a triangle, I cannot make use of that theorem, right? So here, how would I find my AB? I'm going to try and use what I've calculated before, right? So I was told that this line from G to A, it is equal to this line from G to B, right? Meaning that our point G is the midpoint, right? Now, as a result, making use of what I've calculated before. So remember before I said the ratio of your GE to your GA, it is 2:3, right? Now, I want you to note something. Look at your GA, right? Which is this line right over here. This line of your GA is half of your AB, right? So as a result, I can represent my GA in terms of AB, right? So basically this is the same as 1 over 2 multiplied to AB, right? But first, let me cross multiply here. First step would be to cross multiply. So this 3, so 3 GE is to 2 GA. All right, so I'm trying to solve for my AB, right? Remember, so now as a result, so 3 GE is to 2 multiplied by, remember I said my G is the same as a half multiplied to AB. Right, now I want you to note something also, right? Let me try and erase here. If you look into this four-sided shape GEDF, what kind of a shape is that? GEDF is a parallelogram, right? And what do we know about your parallelogram? Opposite sides are going to be equal to one another, right? So these sides are going to be equal to one another. So let me put another line here. So as a result, we can agree that your DF is going to be equals to your GE. All right. So your DF basically, right? Remember we found the ratio of DF before. So here I know that my DF is going to be equals to my GE, right? And why is that? Because opposite sides of a parallelogram are equal to one another. This would be your reason, right? So let me write it here. DF is equals to GE, and these are opposite sides of a parallelogram. All right. So now, as a result, do I have the ratio of DF? Yes, I've calculated it as 1, right? So right now I'm trying to determine my AB, right? So let me just substitute these values here. So I can write this as 3, right? DF is 2 multiplied by a half AB. Now, substituting my values here, 3 multiplied to the ratio of DF, remember I found it as 1R, is 2. Now, 2 multiplied by a half, this would be the same as 1 AB. Now, this would be the same as 3R on the other side, is to 1 AB. And now because I'm looking for my AB, right? Right. So basically here, my AB, it is the same as 3R. Now, the ratio for my DF is to AB. Remember my DF, it was 1R. My AB, I found it as 3R. Now, as a result, these R's are going to cancel out one another, and the ratio here would be 1 is to 3. And this would be your final answer. Right. Now, in the next video, we're going to be continuing with these Euclidean geometry questions. So make sure you stay tuned. Thank you.